Thank you for coming.
Okay. Yeah.
So thank you for our wonderful MC for kind of introducing it. But for anyone who doesn't kind of know my existence or what I do, research engineer, I've been doing virtual production work for 4 or 5 years at this point. I have a decade of research and engineering experience. My last formal position was over at Roche Pharmaceuticals, kind of very far away from here, but I've been tangentially in kind of the live events and generally event space for quite a while now. And one of the side projects that I've consistently been working on is like, how do you do time and synchronization across a large number of devices? How do you scale it to like work over 5G? How do you do it in a way that's extendable? And how do you build a protocol that's actually usable and easy to implement? And so part of my experience kind of comes from the DJ world and like the DJ sync world, where there's a lot of mainstays when it comes to traditional show control, primarily LTC. And, some of the projects I've worked on, are very show control heavy, traditional DJ format. You have a bunch of CDJs, show control software, which takes the timing data, generates LTC, MTC, etc., and takes that and then, forwards it to your front of house and all of your media servers for playback. It works. It's worked for a very long time. It's been kind of a hacky way of doing it. But there's kind of known limitations to it. The second approach that's been pretty standard is kind of your more traditional live band solution where you put LTC in a band track on Ableton Live or your DAW of choice, and you spit that out over your audio channel, and you have maybe some MIDI cues to actually chain presets on things. That's pretty much the standard way of going about this and how people have been doing it for decades, and it more or less works. But it kind of only works when you have a set of linearity. So when you're going from point A to point B, never really fails. But what happens when you're trying to jump around or when you're doing a lot of change segments, when you're not really at this kind of level of time precision and you need something a little bit more accurate and a little bit more flexible? And there's a number of protocols that kind of work to solve some of these problems, but they majority have the same problem, which is that none of them are instantaneous. None of them kind of focus on being able to move time as, a sub-second I item. Usually you have some level of frame delay for everything to kind of catch up and resync. And there's no guarantee that all the hardware does the correct correction on all the protocols. TCNet kind of comes the closest, especially in the like EDM world, but unfortunately it's not well documented. It's a bit of a quirky protocol to actually work around. It's also highly proprietary, which makes it a little bit of a pain to deal with licensing wise. And so, there have been solutions around this. Usually they kind of follow the same trend of like we're running 60 FPS. We have some 30 FPS drop time code that we need to, or non-drop time code that we need to run everywhere, and we'll just, pass that along. So the kind of question I started to work around was how do we make these better? How do we actually take what we're doing from all these different sync sources and actually make something that has more features than just, an audio signal? So it kind of metamorphized into these 5 items, which is how do you make it something very simple to set up? How do you use proper metadata to provide tagging into your time information? How do you work without being tied to hardware? And how do you make it time focused rather than frame focused, which seems to be, kind of the curiosity that I aim to solve. And how do you make it as future proof as possible? Because you want something that's not going to have or feel legacy, but you want something that can evolve kind of consistently. So, like I said, I'm turntablist. I've been a turntablist for many years, and this is kind of where all the other solutions fall flat. One of the indications that I worked on was a show with the Wu-Tang Clan. They, have a live DJ on stage. They're doing tons of track changes. It's a little bit chaotic, but it was entirely a time code show. So how do you work around that problem? How do you solve it? And so this is where kind of the idea of CLX came in, which is clock link exchange. It's a UDP-based protocol that is easy to implement across any language you want to implement. Takes about 30 minutes to get it working. And so looking at those 5 items that we were aiming to solve before, we wanted to kind of hit on those points. The protocol aims to be simple and immutable. So everything that you need to add to the protocol is append only. You can never go back and change any of the protocol without a significant rewrite. But that's nice because you can always make extensions. Super easy, like I said, to implement across languages. It's based on standard binary coding. So really efficient on the wire. It's low latency. We can get down to about a microsecond of time based on the hardware that's surrounding it. It's easily extendable. You can add your own extensions to it and your own protocol messages, and you're not going to break anything inside the protocol. License is open source and it's easy to implement both send and receive. So if you want to be able to use it in whatever program, you can do it relatively simple. And there's a wide array of first-party integrations. That was kind of the core thing that most of these other ones were missing. And when it comes to first-party support, we kind of know all the usual namesakes. We know our Touch Designer, Unreal Engine, MA. These are all things that we aim to support out of the box, and things that we feel like would actually bring us closer to the industry in general in being able to support this on really a number of different shows. And so we've gone ahead and done it. And each one of these, again, open source plugins available, focused around how do you provide this data to be able to be used. We actually just finished the Lua integration into MA. So we have a working example on tour right now in Asia that actually takes in all the time and metadata and does queue firing and execute firing on MA. Similar to kind of deadmau5's chaotic Twitter rant, if anyone is aware of that one. Unreal Engine support is there and fully functional, so you get basically all the same data you would get from any of the other protocols, but with a lot richer information. And same thing with Touch Designer, you get all of your information right there, however you want it. There were a lot of things that came about this protocol, like learning kind of the landscape of how a lot of these things work. And one of the core things that we discovered was like a lot of these protocols are hardware bound in kind of a weird way. Like their TCNet is a very prime example. Like it doesn't necessarily work unless you have some very specific switches. In the case of they're just a lot dumber than most other switches. And so we wanted to make it as easy to work with in terms of packet processing. So a lot of this has been tested on managed switches, multi-VLANs, VXLAN crossing, and validated that you're not going to have a ton of issues. It's literally as simple as it can get to work. It is highly portable. When we wanted to build it, we were looking at how do we avoid real time, and a lot of this came from the audio processing world. How do you do digital signal processing at really high rates? And a lot of that comes from the memory space, so like avoiding heap allocations, avoiding deleting memory, basically things you would do to kind of make it run as fast as possible and not have audio glitches from the DSP side. So all of our implementations follow this process. Leveraging hardware as protocol, that's aiming to be part of our V2, which, we know timestamps are not necessarily going to be accurate unless you have some correction mechanism on both sides. So we want to be able to implement it both as a hardware chip, but then also having the ability to do hardware clocking so that way you have a very solid, accurate timestamp across all your devices. And then finally, providing good working examples. Sorry, mouth gets a little dry. But on that point, we're kind of looking forward to around this protocol in V2, which is doing our automatic time correction, doing AES encryption on it, being able to handle bidirectional streaming from all the different devices. So everything will have 2 channels direct, so you can get information back from the system. Automagical blind failover. This is something we've actually already implemented using kind of our UDP multicast infrastructure. So you can have n number of receivers, n number of senders on the network, and they're all able to just basically coordinate with each other. There's no complex logic around it. They just know how to handle failover across the board. And we let the network handle most of that work. And obviously hardware timestamping is the other issue. So we made a protocol. Now what? Well, we built Clockworks, which is kind of the first implementation of this. The goal was to provide a platform agnostic TCNet show control solution, which we've gone ahead and done. This takes in data from a number of different DJ softwares, processes it, generates MTC, LTC, etc., and sends that out, whenever we need to. The goals were to build it cross-platform, do 4 decks of preview, LTC, MTC, etc., waveform preview, and handle any type of extension on the protocol that you could do, and also be mobile compatible and etc. Actually went through a little bit faster. That was actually the last slide. So open to any questions that people have for this specifically.
So, I guess like I look at it as like a disguised program. So it's something that I could hopefully one day natively take into disguise from, in theater, like maybe like QLab generated. Is it a sound file or
Nope.
is it a?
It's all UDP data. It's binary data. It's similar to how TCNet works, but it's all metadata associated with timestamps.
Okay. And in terms of like the relation of time, is it like a 24-hour clock or is it like a time that can be like anything?
You can be time of anything. So from 0 to 24 or wherever that time exists.
Can it be over 24?
It can be over 24, yeah.
Okay.
So it's integer floating point, or it's an integer timestamp, so you can go all the way to and basically highest level of an integer can value.
Yeah, because like, I feel like, we're limited to like 24 hours with all these things, whereas like, we're not always thinking of a stock in terms of like an hour, we're just thinking of it in terms of like, we want it to start here and end here, so that's kind of interesting.
Would it have an evolution of mentioned metadata, so would it have,
Yeah.
like a song title?
Yep, everything is built in already.
And I noticed the GitHub.
Yep, so we have it up on GitHub. It's open to anyone for use. I'll post I'll share the link out for anyone who wants to use it, but it's just CLX live on CLX spec on GitHub, so anyone can implement it and download it.
Good.
I just signed up for your app.
Oh, awesome.
Is that like you start approving everybody?
Yeah, anyone will sign up. That's just going to be email, but you can actually buy the app or download it on the website already.
Okay.
Yep, there's a download purchase page.
So you're reading like ProDJ links and
Not Pro DJ Link yet, but we support Serato Virtual DJ Tractor, and then eventually, very soon, Pro DJ Link, and then Rekordbox support as well. So all the software platforms that are not CDJs at the moment.
what about Phrase?
We get Phrase and we get BeatGrid.
Hotkeys, memory keys.
Hotkeys, that's something we're working on, but we have a whole component for handling that type of data. We call those events in our system.
It will work. It's not.
It will work. It's basically an extension. It's part of the protocol, but you can set it up to work.
What about the new, not the new library format, but the new?
It doesn't leverage any of that at all. It does all of its own processing. So you can use whatever library format is built into the software. As long as it's connected and communicating, it'll work.
Is the ProDJ more of a getting alpha data on board?
More or less, yeah. Yeah.
Instead of frames, it's like it would be like.
Yeah. Yeah.
Milliseconds or microseconds?
Milliseconds on the time.
Are there implementations of this?
Yep. On our website, CLX spec, we have C++, Unreal, Touch Designer, all implementations available.
Are you gonna go DJ tonight? Show us how.
Not tonight.
Are you constructing waveforms or are you getting waveforms?
We're constructing them.
You're just.
I missed the beginning of the presentation. Did we talk about scratching at all? Is that incorporated?
Yeah, it's able to handle that type of processing.
Like we just said to the most.
Yeah.
Yeah.
All right.
That's been great.
Thank you.
Feels like the future is already here.
Short and easy talk for the end of the day.